Okay, so here we have on this problem two cases. First one is we have a mass of copper oscillating at a frequency of 300 Hz, and the second case is that we have the same mass but submerged half of its volume on water, and we need to find the second frequency at which the mass is oscillating. First, we need to get into account that the mass is equal to the density of copper times the volume, and then we need to find the tensions for this and for this wave. For the second wave, for the first wave, we have that the mass times gravity, which is the weight, is equal to the density of the copper times the volume times the gravity. And for the tension 2, we know that the weight minus the buoyant force is equal to the density of copper times the volume times the gravity minus the density of water times the volume, which is half of its volume, times the gravity. Now, we know that as it is a string, the velocity is given by the formula of the square root of the force over mu, but which we have two velocities, we have two different frequencies. The velocity 2 is also given by force over mu. Now, we know that also the frequency is equal to velocity over lambda, and the frequency 2 is equal to velocity 2 over lambda 2. Now, we can get rid of the velocity and with lambda by dividing these two velocities, these two frequencies. So we have the f2 over f1 is equal v2 over v1, which is this time is equal is the tension 2 over the tension 1 is equal, we need to substitute, the tension 2 is this thing, so it's the density of copper minus 1/2 of the density of water over the density of copper square root, and this is going to be, after we substitute the values, is 96 minus 1/2 of 1, which is the density of water, over 8.96 square root. And after it, we need that the frequency 2 over frequency 1 is equal to 0.9717, which is, after isolating, we know the frequency 1, which is 300 Hz, and we need to multiply this. It's going to be 300 Hz times 0.9717, and it's going to give us the result of 291.5 Hz.